Okay, I'm just going to add a quick screen here. Like I said, you don't have to jot this down, but if you remember back in geometry, we'd have these right triangles, right? And we might call this angle A, angle B, and angle C, right? You remember sine and cosine and tangent, right? SOHCAHTOA, sine is like if I want to take the sine of angle A, put a theta in there, right? It's whatever this side is divided by hypotenuse, right? A over C. And then the sine of angle B, now we'll call that an alpha, right? Would be B over C, opposite over hypotenuse. Cosine is adjacent over hypotenuse. But the only thing was, it was only like these two acute angles, right? So it would only be from 0 to 89.99 degrees. And maybe you've seen somewhere that, you know, in physics or science class or wherever, you can actually take the sine of angles bigger than 90, okay? And so we have to take the trigonometry out of the right triangle, which means we'll have to start looking at the unit circle, right? So that's kind of the setup where we're going to start with 11.1. And to talk about the unit circle, we need to talk about angles in the coordinate plane. So let's go to, make sure I am recording, yep. So, rotation angles and terminology. Real quick, you might see some Greek letters. Let me just run through them real quick. It's not really complicated. Let's go to our notes page real quick. A couple pages over, page 178. So, some Greek letters. That we commonly use as variables. Not all of them, just a few you'll see in this unit. Okay, you're probably all familiar with this one, theta. And by the way, we most of the time use these for angle measures, right? And it's just a variable like X, Y, or Z, right? But when we start talking about angles, it's nice to have a different set of things, right? So hopefully you've heard about theta in geometry class, right? There's also one that looks like this, and that's just the Greek letter alpha. All right, kind of looks like a fancy A. And then this thing here is the Greek letter beta. Okay, so if you see any of these Greek letters in your homework or as we go through the notes, don't panic, right? They're just variables, that's all, okay? And we generally let them stand for angle measures, all right? Everybody has that, and we'll go back to this first page. Okay, so let's talk about angles in the coordinate plane. So if you see over on the right here, we have the XY coordinate plane, and you're familiar with the quadrants, right? So over here is quadrant 1, quadrant 2, quadrant 3, quadrant 4. And how many degrees all the way around if I was to make a circle in the coordinate plane?
360.
360 degrees, okay? And at some point, we're going to change from degrees to radian angle measure, but that'll be a little bit later, okay? So generally, we start an angle in the coordinate plane with the vertex here at 0, 0, right? And this will be the initial ray of the angle, okay? And we open up the angle, usually in this direction, and that's a positive direction, okay? So counterclockwise is positive. I know that goes against maybe your intuition, okay? But counterclockwise is positive, right? And then wherever the angle stops here, that's called the terminal ray, okay? And we also have what's called a reference angle, okay? So you remember in our triangles, right? First of all, let's do this. If we're here, this is 0 degrees. Everybody agree? And if we open it up to up here, this is 90 degrees. And what is it all the way out here to the left?
180.
And then if we go all the way down here to the bottom, what was that? 270.
270, and then we turn to 0, be 360.
Right, and this would also be 360. You could go around again, right? You know, like 540 and all that stuff, okay? Some of you skateboarders know some of these angles, okay? But if I draw an angle if I start here and go this way, that's a negative angle, okay? I can do too many of those, all right? But positive is counterclockwise, all right? Coterminal angles, it just means they have this terminal ray at the same place. So the reference angle, and this will be the important part of taking the trigonometry out of the right triangle, okay? So the reference angle here, whoops, always gotta need some new equipment. Reference angle is just a positive acute angle formed by the this is up in here, by the terminal side of the angle and the x-axis. So if we go up to the diagram here, you would agree that this angle that they have in here is greater than 90 degrees, right? Okay. But if we take this very same angle and then remeasure it from the x-axis here that it's real close to, you would agree that that's less than 90, is it not? And this is what's called our reference angle, okay? All right? And so this is going to be the key part of taking it out of the triangle, right? Because in the right triangle, the two angles we've done sine and cosine with are less than 90, okay? So let's take a look at an exercise here. Let's see if we can work out some different angle measures as we go around. And you might have to make a little sketch for some of these, okay? So these are the following angles given by theta, right? Theta, good grief. Theta is it's just a variable, right? Draw a rotation diagram and identify the quadrant, right? 1, 2, 3, or 4 that it falls in. So we're starting out pretty simple. So in this first one here, theta is 145. Let's make a quick sketch. Well, I don't know exactly. Where's 145, right? We don't know precisely. But it would open up, it's greater than 90, wouldn't you agree? And less than 180. So wouldn't it be, oh, the screen's dancing. Let's let the screen stop. Wouldn't that angle open up to about here, like that? Wouldn't that be about 145? We all agree? And what quadrant does that fall in?
That falls in the terminal.
Which quadrant? 1, 2, 3, or 4?
Oh, 2.
Quadrant 2, right?
2 and 1.
No, just no. Not
Oh,
1.
just 2?
Yes, 2, right? Remember, the angle starts here. This is quadrant 1. This is quadrant 2. This is 3, and that's 4. They want to know where the angle terminal side is, what quadrant, not the initial side. Now let's take a look at 320. Make a quick sketch, right? And we always start here, okay? So this one's going to open up, well, it's going to be somewhere between 270 and 360. Everybody agree? So down here is 270, right? So it's going to be bigger than that. So it might be kind of like this as we open up around here, like that. 320-degree angle. And what quadrant does that fall in?
Quadrant 4.
That's 4. The Roman numeral IV we usually use for quadrants, right? All right, what about 72 degrees? Should be simple. It's less than 90, so it's probably like right here, right? What quadrant is that?
Quadrant 1.
That's in 1. All right. Well, now we have one that is negative 210 degrees. So negative angle means we're going to be going clockwise from our initial point here, right? 210 degrees. Well, we could think of this one as 90 and 180 and 270, like if we're going backwards, right? So that would open up, right? If we go here, there's 180, right? It's not quite there, so it might be like to here. I don't know, just a rough sketch. All right, that's a negative angle. See how it goes the other way? See how it goes clockwise? So what quadrant do we end up with there?
Quadrant 3. Oh, no, 2.
2, right? Okay. All right, you guys try this last group here. Make a quick sketch of the angle and see if you can work out what quadrant that it falls in. I'll give you a second. Make a quick sketch. What quadrant do we get for C?
3?
Yeah, quadrant 3, down in here somewhere, right? It opened up here, positive, okay, so 3. Be careful, F is a negative, right? So it goes the other way. Can we get a quadrant for F? 3 have negative 310. Let's see, there's negative 270 and then a little bit more, right? Did that confuse you? So a quadrant for F? Quadrant 1. Okay. G's a little bit different, right? 460 degrees. Probably going to go around more than once, right? Well, there's 360, right? And we need another how many degrees to get to 460? I just went 360. How many more degrees do we need to get to 460?
160.
100 more, right? So more, a little bit more than 90 like that, right? So see how that works? So what quadrant is quadrant 2? Okay. And the last one, negative 400. Remember, we're going clockwise with this one.
That means it would be quadrant 4.
Quadrant 4, right? So negative 400 is bigger than 360. So there's 360, right? We need another, what, 40 more like that? I don't know, roughly. So in quadrant 4. Can you get the idea here? All right. Let's go to this last question here. It's the same as these, but they make it over. In which quadrant will an angle standard position fall if it measures 860 degrees? So you skateboarders probably have a better time with these than others, right? What quadrant is that going to end up in?
Quadrant 2.
Quadrant 2? Yeah, I think you might be right. Let's see. 860, right? So if we start here and go, there's 360, right? 360 and 360 is what? 720, isn't it, right? So if we come around here, isn't that 720? And then how many more do we need to get to 860? It's 860 minus 720, because we just went around 720 degrees. Is it another 140?
That would be 140.
So another 140, I don't know, somewhere out here like that, right? Of course, we're not being exact. Okay? So another 140 degrees, and it falls over here in quadrant 2. All right. Anybody have any questions on these? How to work out these angle rotations and what quadrant they're in? Okay. All right. Let's go over to the next page. We're going to skip exercise 3 for now. And then I think, let's see, did I want to skip 4? Somebody doesn't have all these have measures. Yeah, let's not, we don't have to do number 4. Okay, now let's talk about the reference angle, okay? So as we went around there, we had a bunch of angles that were greater than 90 degrees, right? But wherever the angle ended up, it was some distance from the x-axis, okay? So our reference angle is going to be like the equivalent positive angle from the x-axis, always the x-axis, okay? So let's look at an example. In part A, angle beta, right, just a variable, is 160 degrees. So let's do what we were doing before. sketch that angle in here, right? So it's not quite 180, right? Right, we'd all agree that that's 180, okay? So if we go around here to 160, about like that, wouldn't it? Right, it rotates around to the second quadrant. So if this is 160, and here's 180 at the x-axis, right here, what's the measure of our reference angle here?
20.
20 degrees. And now we have an acute angle to work with, okay? If you can read that. So 20 degrees would be what's called our reference angle. So a 160-degree angle in the coordinate plane works out to a reference angle of 20, right? And it's always with the x-axis. So let's try the second one. Beta is 300 degrees. We know how to do this, right? So it's bigger than 270, but not quite 360. If we rotate all the way around, wouldn't it be about here, right? Like that. Okay, let me get rid of that mark. And again, the reference angle is always with the x-axis, okay? So if this is 360 degrees, and this is 300, so this reference angle is 60 degrees. Kind of getting the idea? So wherever you rotate your angle to, the reference angle is always the angle formed with the closest part of the x-axis. Let's try the next one, 210 degrees. 210. We're above 180, right? But not quite to 270, right? 180, a little bit more here. So here's my 210. Here's my 180, okay? And it's always the reference angle where it's closest to the x-axis, okay? So what's the measure of my reference angle?
40.
All right, everybody agreed to get from 180 to 210? My reference angle is 30 degrees. Okay? Let's try 78. Well, this should be pretty simple. That's not quite to 90, is it? Well, what's the reference angle here?
12.
No, it's always with the x-axis. Always with the closest part of the x-axis. I know you want to say something different, but what's the reference angle?
78.
It's just 78, right? Because it's already acute, right? The reference angle is just some acute version of the angle you're given. 78 is already acute, right? So reference angle 78. Okay? I don't want to deal with these negative ones here right now. But do you get the idea, right? It's always the angle formed with the closest part of the x-axis. So like in example A here, right? We had to do like 180 minus the 160, okay? In B, we had to do 360 minus 300, right? Like the way you subtract depends on where the angle ends up. In part C, we didn't do 180 minus 210, we did 210 minus 180, right? So it's just always the angle formed with the closest part of the x-axis, right? And that's basically the gist of this first lesson here. Does anybody have any questions? Any part of this confuse you? Because you need to know this before we move on. Anybody? All right, well, let me jot down your problem set, what that'll be. It's whittled down a bit. So it'll be numbers 1, A, B, and E. A, B, and E. And 2, A through C. All right. Any questions at all on these reference angles? We need to know reference angles. So we can take the trig out of the triangle. Okay. All right.